Hello and welcome to my video about rotations, or another word for it, non-mathematical word, is spin. So you can just imagine just spinning an object. The most mathematical way of talking about it is rotating the object. So from now on I'm just going to use the word rotations, or rotate. So you can see here that we have the original shape, which is in purple, and in yellow it says rotate about the origin. So just a reminder, the origin is the dead center of our x and y axes, where it's 0, 0. So our origin is right here, right in the middle. So it's rotating about the origin. It means rotating, it's spinning around. Maybe I'll write that down. Spinning around the origin. So it's spinning around that one point. You can actually spin around any point, but it will change what shape you have or where your shape is going. But the most simple way of spinning or rotating is about the origin. Okay, you can rotate about other points, but the most basic, which we start off with, is about the origin. So simply, we normally rotate clockwise, but we can also rotate counterclockwise. So so we have the notation down. This is clockwise. This is counterclockwise. So in blue, we have that from our purple shape going to the blue shape, it rotated 90 degrees clockwise. So going this way, 90 degrees. A right-hand turn, or 270 degrees going all the way around to this way. Makes sense because it is 3 times longer to go the left or counterclockwise way than to go the clockwise way. So we normally do start with whichever way is shortest. So normally when we describe a rotation, we talk about whichever way is shortest. So 90 degrees clockwise is the better description. And in green, it is 90 degrees counterclockwise from our original shape. So you can imagine that this point in the middle here is fixed. It's stuck there. So if you just put your finger down there and flick your shape right here, you can see that this corner spins around to become this corner. Right? And so that happens with every single point. If you flick that shape, it goes up and spins around while this point is centered or stuck right there. So that's 90 degrees counterclockwise. Or you can do it the opposite way and go 270 degrees clockwise. The last point here is the final red shape, which is 180 degrees, where this corner goes all the way around to here, 180 degrees clockwise. Okay, again, that point here is fixed. It hasn't moved, but we're rotating that corner around 180 degrees. So it could go 180 degrees that way, or 180 degrees this way. It's the same distance, or the same number of degrees, the same amount of spin. Alright, so that's just talking about it in terms of shapes, but really the question is, most people's questions are always, well, what do I do in the question? Okay, well, that's fine. Here are 2 questions for you. We have one single point, this point, circle point, which is in purple and is called the original point. We are going to be making images, a red image that is rotated 90 degrees clockwise about the origin. So remember, clockwise means it's going this direction, and it's 90 degrees. So what's helpful about going about the origin is whenever you talk about 90 degree increments, it's always one quadrant away. So let's just let's think about where it should go logically. Well, if we kind of think about it as how far away it is from the origin, it needs to always stay that far away. So if we rotate it 90 degrees, like I just made a line here to the origin, if I make another line here, you can see that this here is a 90-degree angle. So it has moved 90 degrees if I put my circle right there. Maybe I'll do a proper circle, or, yeah, I'm not even gonna. I don't know. It's not perfect, but anyways, you get the idea. So it's moved 90 degrees. So I'm going to just erase all this so that I have more room. Okay, so we have now made the image, but let's see if we can see anything interesting about it when we find the coordinates. Remember, coordinates are always written x, comma, y. So let's think about the original. The original has an x of 1. So x is, whoops, not x, 1, comma, and then the y is -2. So -2. And what you're going to see here is that our red shape seems to have the same numbers, but kind of different. So our x is -2, and our y is -1. So there is some relation, but they kind of flip and negatives and whatever. So I wouldn't focus on it this way. I would focus on just thinking about it visually. Okay, I know that sometimes is difficult, especially for the more mathematical minded of you. But thinking about it visually will definitely help. There are ways to do it without thinking visually, but it's too complicated for grade 6. Okay, so that was a 90-degree rotation clockwise about the origin. What about 90 degrees counterclockwise? Well, again, we can make a line directly to our origin. Okay, and then think about what a line would be directly 90 degrees to the one side of that. So it would be right there. Alright, so now we have that point. Now, I do want to point out something that is more important to notice. But let's first of all just notice that we have to erase all this. And our x is 2. So 2, comma, and our y is 1. So again, notice that it's the same numbers, it's just negatives and flipped x and y have been flipped. So there are things to notice here, but this is what I want you to pay attention to the most. You can see that the amount away that we are from the origin has stayed the same. 1 to the right, in this case, and 2 down. And on the other one, it's 1 up and 2 to the right. On the other one, it's 1 down and 2 to the left. So you can see that there is a shape there that, like, the directionality of the shape of the point of the circle changes, but it's the same distance exactly away from the origin. So 2 one direction, 1 the other. 2 one direction, 1 the other. So I hope this helps explain rotations for you. I'm going to actually just go back to this screen here. I hope this helps, and good luck.